this little patch here is good. So this is going to be 30 minutes on a quick update on what's happening in GHC land. I think don't wait till the end to ask questions. Let's just say we will be finished in 30 minutes. Just ask questions as we go along. And the lights are very bright, so I'm going to stand somewhere where I can see you as well as you can see me. So, what's happening in GHC land? Well, a lot. It's kind of not so much a compiler, it's more way of life. So, there's lots of activity. Here's the commit history from conveniently accessible from GitHub these days. So, this line that you can't see here is 50 commits a week, and these are weeks, and this is the last year. So, we're not really running at 50 commits a week, but we're kind of getting close to that sometimes, and a lot more sometimes. So there's really a lot happening, and more people are getting involved. So this is a rather approximate list culled from commit logs of who's actually committed stuff. Lots more people have contributed by the way of bug reports and so forth. So this is a very small subset. So thank you everybody who's taken time and effort to boil down bug reports into small things, or better still, to make patches that we can use to fix GHC. So what's hot? During the last 12 months, we tried to quickly summarise what's been happening in the last 12 months. So one thing is we added a little bit of syntax, somebody mentioned yesterday, lambda case, so that you can, that annoying moment when you want to do a lambda that does multi-branch pattern matching, you can now do, and this multi-way if thing. I'm still wondering about this because it doesn't work so well if they're nested, then the sort of layout doesn't work so well. But it's very convenient for this situations like the one shown here. So this is very superficial. In fact, the internal abstract syntax has always been able to handle this. It's only been the concrete syntax that has not. Then what? Much more substantially, and this has occupied me for a good chunk of the year, kind polymorphism and data type promotion is finally, so it was sort of, a lot of the code was in 7.4, but it didn't work, and it wasn't advertised in 7.4, which didn't stop a lot of people reporting bugs, which were useful because every bug turns into a regression test, so thank you for those. Kind polymorphism I now see as, it's just like ML polymorphism. It just lets you do exactly what you'd expect in the old way. Well, why would we ever have done that? So here's T, some data type T, that has, it applies one of its type variables to another one. And of course it should have the type for all kinds K, K to star, so that A is kind K. It will work then on more arguments. Why wouldn't it? So I thought it was going to be easy to implement. It turned out to be a bit harder. But the new type constraint, the new constraint gathering mechanism that I told you about last year has also enabled us to implement deferred typos. This was an example of somebody, I've forgotten the chap's name. Oh dear, how embarrassing. But he not only produced the idea, but also a patch. It turned out to be a sort of grotesque hack, the patch, to implement deferred typos, which Pedro described in his talk yesterday. But the nice thing was that the constraint gathering mechanism meant it was a simple and beautiful way to implement it much more directly. So we did that. I mentioned that as a little variant, you can now do holes as well, but I only told you that, so I thought I'd just show you what it looks like very briefly. There's holes. Which of these many compilers does the... yes, here we are. So here's the program. Can you read this? No. Do you want it bigger? Would that be helpful?
Yeah.
Bigger. How does it manage? Oh, there we are. Look. Even I can operate a GUI. Ooh, there we are. Good. But then I have to make it smaller and then bigger again so it fits the screen. So here's a program with a hole in it. So this is f of x, and this underscore is a hole. It just says, here's a bit of code I haven't written yet. And then, so this is a list with 3 elements, and a hole, an x, that's this x, and then a lambda y dot another hole. Right? And they all live together in a list. So somehow the type of a hole and the type of x are going to be related to each other, and these two holes are going to. And then here's a main says we're going to print. And what are we going to print? Well, we'll apply f to reverse. As you can see that x is going to turn out to be a function, seeing as it mixes up with this lambda y thing. So we'll apply f to reverse, and then we'll pick the first element of the list, the 1th element, which turns out to be the one that's okay. It doesn't involve a hole. So here we. Where's the shell? Right, so let's compile it. And once my machine's woken up,
Hello, good morning, yes. So it gives you a nice, the thing points to the right place. It says here's a hole, and it tells you its type. Right, so the type of it, this is just all stolen from Agda, of course. And since we don't have a nice cool GUI like Agda, we have to give you some clues about what's going on at that type. So it gives you a selection of the value bindings that enclose the hole, along with their types. So you might think, what is T and what is T1? Well, F has this type, and X has type T to T1, so it gives you some clues about what might be around it. And the same for the second hole. And the names of these type variables match between the two error messages, which wasn't entirely trivial. And then, even though it's got holes in it, we can run it. Oh yes, and we successfully reversed success. Don't you think that's cool? Clever guys, those Agda chats. Yellow is working on giving us natural numbers at the type level, which is coming along. And let's see, performance improvements. Yes, so the constraint solver. Dimitrios and I have rewritten the constraint solver at least twice this year. And every time it gets shorter and more beautiful and faster. So now I feel as if I understand it much better than I did a year ago. The glorious new code generator, I told you about this a bit last year. This has been a long-running project, at least 5 years of sort of interns have been cast into this particular trench. But finally, their prone bodies have filled up the hole, and in particular, Simon Marlowe has poured the last bit of concrete. So the idea is that at the moment, GHC takes STG code and converts it into C++ that's kind of CPS converted. There are no... why don't you come in, there's plenty of chairs, and I will not be offended if you simply walk past in front of me. And in fact, I would be affirmed by the fact that you wish to participate. That's why about how as you pass. So this C++, because we manifest the stack, everything's very flat, it's really difficult to do much optimization at this level. So even though one of the code generators is LLVM, it's like taking LLVM and chopping all its arms and legs off and putting it into parallel mix. It doesn't do really well here. So now we're making a simple pass to C++ with procedure calls, then doing a chain of optimizations, and then converting that into, that includes removing the procedure call stuff and CPS converting so we can heap allocate our stacks. And then we can go around this way. And this has a different representation for C++ based on Hoople representation, and it's so cool. And finally, Simon has made all this work. And in fact, it's going to be, I think 2 weeks ago, he pulled the switch, so that in head at least, this is the default path. So now the joyful time comes when we can do cruft removal, because there's much cruft associated with this. That'll be fun. And there's lots of new optimizations we can do on the C++ code, which is always way more fun. So those numerically intensive loops where Johan looks at it and Roman looks at it and says, there's an extra instruction there, we can finally do something about that. That's cool. That will be in 7.8. And there's new opportunities for optimization. But because we can do all the traditional compile optimizations. But rather to my astonishment, one user has already said the new code generator makes his code go twice as fast. I wasn't expecting that. Isn't that amazing? So cool. Now, still on the code generator side, the Win64 port is out, which is great. Thank you to the industrial Haskell group for funding and organising that, and indeed for executing on it. That's really helped. And Ian Lino has also been working hard with a few other people on making GHC into a full cross-compiler, so you can sit on one machine, one architecture, and cross-compile for another. That's nearly there now. Parallelism. What's happening on parallelism front? Lots of stuff. Simon's work on allowing you to change the number of virtual processors at runtime. I'll show you that very briefly. Jeff on SIMD instructions, bits on Cloud Haskell and Data Power Haskell. And I'm going to get these say a bit more about each of these while their authors will. But Simon is not here because he is giving a tutorial about parallel Haskell right now. So that's why he's not even in the book. So this is changing the number of capabilities. Capabilities is GHC's strange name for virtual processor. Right, so pretty much there's one per physical processor, but sometimes it's nice to be able to change the number of runtime. And briefly you couldn't. You had to say, when you started your program, you had to say plus RTS dash n and then the number of processors you wanted to use. That's not very user-friendly for end users. And it's quite nice if the program itself can say, I seem to be on a multiprocessor. Maybe I can ask the Haskell runtime to use those multiprocessors. So that's what we can now. And that's very nice. So it's called, you say, you can ask how many processors there are, and then set the number of processors you want to use, in effect. And so, when we're not using this very much, it should allow us to dynamically tune how much parallelism is going on, but at least here's a little test program that shows this is thread scope, and I think this is a little artificial program that sort of reduces the number of capabilities and then increases it, and you can kind of see some processors going idle for large chunks, and that's why. So that's a modest but cool refactoring of the runtime system. Now, what else? Cindy, Jeff, where are you? Jeff? Tell us about SIMD support. Is this switched on? Hello, hello. No, it's not switched on. Something is not working. It has a red light at the bottom, which...
There.
There
much better. Okay. Okay, so SIMD support in GHC now. There is low-level support for the primops necessary to generate SSE instructions. There's also support in the vector library now for fusion with SIMD operations, and in fact there's support in DPH for SIMD operations. So let me give you the good news here. This is a simple plot of a dot product, various implementations, and how it's scaled up in the number of threads. So you'll see this bottom line here is DPH with SIMD support. So you're taking advantage both of the processors and SSE instructions. Various other implementations with and without SIMD support. Unfortunately, there's some bad news here, and you can kind of see what part of the bad news is if you look at the vector library implementation of SIMD. Not doing it so hot, not as well as the C implementation, and that's because of register allocation issues. The other bad news is this is not yet in head. And the excuse that I've been giving is that the new code generator has not been turned on, and I was going to wait for that. Unfortunately, I no longer have that excuse, so I've really got to get this done now. So it will go ahead soon. Of course, if you want to install it and play with it, which I would actually really appreciate, go to the SIMD page on the track wiki, and there are instructions there for how to do that. So you're certainly welcome to download patches to the GHC and the vector library and DPH and get it all working. It's not that hard to do, it's doable. So if you like, please play with it and let me know how it turns out.
Not just please play. Who would like their program to run 4 times faster? Yay! Yay! Play! These instructions are amazing. DPH, Ben. Tell us about DPH.
Hello. So in my talks at ICFP, we now have DPH compiling programs and then running them.
You've got switched off again.
Oh,
it's on.
It's on?
It's all right.
Oh, okay, fine.
Right, so we've got it to run programs asymptotically well. Barnes Hut has been a thorn in our side for a long time, but now we fixed this replication problem, sharing problem. And now we have to make it run fast. So there's 2 things on my plate when I get back to make it run fast. The first thing is that we have to fix fusion for these, the new array representation. So up until now we were using data.vector as the backend library with the distributed types layer on top, and that has to be made to work for our new array representation. The second thing is that DPH is producing lots of very fine grain operations, so operations on very short vectors. For instance, when you have a divide and conquer algorithm, you might start out with an array which is this long, 1 million elements long, and then at every stage it chops it in half, and then you get shorter and shorter vectors in the leaves. If you remember, there's some plots I showed in the repo talk. It takes on order of 100 microseconds to actually schedule a parallel computation. So if your little operation on short vector is shorter than that, then you're just wasting time in scheduling. So it looks like the other thing I have to do is some kind of dynamic granularity guesstimation. So when DPH wants to do an operation on a vector, it analyzes, it's going to have to analyze the size of it and then guess whether or not it's going to be useful to spark off a parallel computation to run that, or just run it in the main thread. And I think with both of those pieces of work done, then we'll get down to sensibly performant programs. Okay.
Cool. Thanks. These 2 things kind of fit together.
They do, and the SIMD instructions as well. So Gabby's work with the vectorization avoidance is also another piece in this pie. So we have to make that work somehow with the SIMD support.
But particularly the SIMD instructions that Jeff described, you have to use different data types. You have to use a vector of quads, right? Rather than a vector of floats, a vector of quad floats. So it shows up in your source program. Right? So that means that it goes really fast, but you do have to change your source code. The promise of DPH, right, is that we'll be able to take programs that just use vectors of floats and vectorize them,
yes, and
make them run using SIMD, and then they run 4 times as fast without you having to lift a finger, and that'd be really cool. So I like the way these things fit together. The other thing to say about DPH is that it's a big, long-term, ambitious project, right? So doing this Nestle stuff for a high-order language with full recursive data types is very ambitious, which is why it's taken us 5 years to do it. We've been promising it every year.
Yeah, but lots of pieces that come out of that though. So data.vector, which Roman wrote, was directly to support DPH, and then we cut that out as a piece and released it as a separate library. And then REPL is also part of the DPH project, which we cut out and released as a separate library. So we're giving you pieces of it along the way.
But I say this not to really to encourage you to participate in this, because at the moment this big ambitious project is kind of getting to the point where it's almost almost usable. And if we can make it useful, if we can achieve this business about nested data parallelism for Haskell, I think it'll be a killer app, a real well beater, because it's lets you write data parallel programs in such a more flexible way from a programmer's point of view. I think it's brilliant. So we've just got to get over that hill. And we could do with some people to give it a try, even though, the moment you need to baby it along and talk to Ben a bit, it would really help us to have some more applications. So if you're interested in parallelism, particularly data parallelism, talk to Ben. It would be actually really helpful to us, not just a nuisance. So please do that.
Yes.
Right, thanks, Ben. So what's next? So that's sort of what we're up to kind of at the moment. Just on the immediate horizon, here are the things that are on our mind, on my mind at least. One is, I've been promising to have an overhaul of template Haskell for some time. I wrote a blog post about how a proposal for how to do this that people didn't stick up on too much, so I think that's the plan of record at the moment. That was like 2 years ago, and I haven't done anything on it since. But at the Haskell Symposium yesterday, a surprisingly large number of talks said, oh, well, we did this using template Haskell. But template Haskell it could be so much better. And this is the, roughly speaking, this is the fix. I can't find any way to sort of have a glorious unification, exactly one mechanism for doing everything you want to do in template Haskell. So rather than having one mechanism at the moment that's a bit unsatisfactory in many ways, we're going to split it into 2. So you'll have untyped quotes and splices, which are quite similar to what happens today, in which you can explicitly use data constructors in the template Haskell language, the template Haskell syntax, and you can pattern match it, so you can take trees apart as well as put them together. But it's untyped in the sense that you don't get a guarantee that the program you produce will be well typed. And that in turn means that you get less guarantees about what you're doing. When you're writing the code, you don't get that type checker is not being as helpful to you as it should. So typed quotes, this is really exactly as in MetaML, more restricted in some ways in that you won't be able to analyze expressions, you won't be able to use explicit data constructors, and in fact it'll only work for expressions, not for patterns and declarations and types. But it will give you the typing guarantee. So I think this will clean it up a lot. Here's what you might see. An old style quote has type QX, and a new style quote will have type TX with list of bool reflecting the type of the thing inside. So this stands for typed expression.
Simon?
Yeah?
Is that going to be polymorphic?
Is it going to be polymorphic? It'll be exactly as polymorphic as MetaML is. Same design, really.
I'll look up the answer.
Yeah. You won't be able to say TX for all A to A. No, it'll be sort of monomorphic in the way that Haskell data types usually are. Yeah. Yeah?
Could you have a left expression?
Inside the quote. Oh yeah, you can have any expression inside the quote. Yeah, arbitrary, 10,000 lines of code between these two. That's fine. Yeah. But it only has one type. Was that what you meant?
Yeah, I was just wondering, so how the syntax tree is constructed where you have typed left expressions.
Oh, that's exactly as now. So it's so the difference will be that you get a type guarantee about how splices fit together. Let's see. Also on the horizon, this is sort of a Cabal-related thing. At the moment, there's this really irritating thing that if you've installed a particular package, let's say containers 4.5,
and Cabal has said, oh, I've done my homework, and you need DeepSeek 1.4. Then it installs it. And then you want to install some other package, but it doesn't. It says, I really need DeepSeek 1.2, and I need containers. Now you're stuffed, right? Because you can't have two. You can't install whatever it is, containers 4.5 twice, right? Because the package database says, oh, we've got containers 4.5. This is stupid, right? We should fix this. And where's that going? Yeah. So this is. So we need to change it to GHC and some little changes to Cabal. This is very fixable, and will be fixed. I think I haven't really talked to anybody. I haven't talked to Ian Lino and Paul Capriotti and Simon Marlowe about this, but here's my plan. What we might do. I don't think we're going to wait until next ICFP to make a new release. There's a lot of stuff sort of coming down that's nearly ready. So I think we'll end up releasing GHC 7.8 kind of Christmas or New Year-ish with a new DPH release. I asked Ben about this, right? The new code generator, the template Haskell overhaul, SIMD instructions and type holds. I hope. That's my plan. So it's a lot of fun, and really we need your help more and more, because GHC's attack surface is getting larger all the time. So we need more and more people to populate the surface and do good things. So please do join in and roll your sleeves up and look at the code. Those who have started looking at the code have not been too badly psychologically damaged. Any questions or comments? So comments are fine as well. Yes, Duncan.
Well, I have one more feature, which is stuff to do with runtime system event log profiling. There's some new stuff in there, some new events.
Oh, just briefly. That's fine. Come on, tell us about the event log briefly.
Yeah. So
you have to switch the microphone on somehow.
Yeah. So you've seen Photoscope. People have shown you Photoscope graphs. This is all based on events that are generated inside the runtime system and logs to a binary file. As part of the parallel GHC project we've been running for the last couple of years, we've added a bunch of new events into the runtime system so that you can log. So in particular, there's now a new debug trace event, which works similarly to debug.trace, which spits things out to standard error. This now spits it out to the event log. So you can have those, well, one is faster, but also you can see them in order with respect to other events. We've also got new events for keeping track of how operating system threads correspond to Haskell capabilities, which will let us do things with Linux Perf, so we can match up kernel events with Haskell capabilities. And there was one more which I've forgotten. Yeah, so more stuff in the profiling in the event.
So you can split out these events, and then how can you look at them?
Oh, using GHC events show the command line program. Or you look at them in Photoscope, which also has the event list.
Yeah.
And you can scroll to the bit and zoom in. Question?
Is there any way to get these events to show up in the profile? Because now when you see heap profile, you sort of have to guess, well, I think something happened here when it started changing behavior. It would be really nice to be able to get little markers in the heap.
So something that we have been doing in Photoscope is that you can have a marker so you can see like phases in the program. So in Photoscope, it's showing you those color graphs, so you can get a... No, what I think we should do in the longer term is to have heap profiling, the other profiling mechanisms also go through the event log. And then we would be able to visualize them together in things like Photoscope, which at the moment we can't do.
There's a little project for somebody who'd like to do that. Any other comments, questions? Norman, you're closest to the microphone.
Is there someone who can say, perhaps during the break, a bit more about the plan to get sort of your full orthogonal cross compilation? That's been waiting for that for years. So,
I think probably Simon is your best bet for details.
Okay.
Is beyond my ken.
Anyone else in the room?
Yes.
Can any of that?
Roman, you had this is a cross compilation question. Roman was next.
Is in the new code generator diagram which you showed.
Yes.
Where does LLVM sit?
Oh, LLVM sits back here, right? So, yes, here.
But that's the wrong place for it to sit.
Well, I know, but the trouble is that LLVM would like to sit sort of here, right?
Yeah.
But we allocate our stacks in the heap, right? And so, and the LLVM thinks that it knows something about stacks, but actually we know all about stacks. We know every byte of where the stack is allocated. So there's another research project for somebody to figure out how to make LLVM interoperate with something which has a million stacks in the heap that move around, and where you need to do heap tracing through them. I believe in principle there are some bits of LLVM that were intended to support that, but I don't think it's actually at the moment. But if you do, it's an open source project. It was just this was a path that made us move in that direction, right? We're in better shape for doing that if you can figure out how to do it. But we didn't go all the way in one jump. Michael, you have a...
So on the expression holes, can we get holes in the types? I want to be able to tell it. Where GHC is not able to infer the type for this, and I'm not able to think up what the full type is, but I can tell it a little bit about the type, and then maybe it will be, based on that, be able to figure out something.
Oh, so you'd like to say f as type underscore arrow underscore?
Yes. And
yes. So
maybe
tell me what those underscores are.
Yes.
Yes. That would be cool. And I have, at various times I've thought, that sounds easy, let me just do it. And then sort of several hours later I realised, damn, that's actually quite tricky. Because there are things like, it might be really for all A, and then the underscore is really A arrow B, where B is down further out.
Yes.
If you can figure out how to do that, it'll be great.
For context also.
That's right, you'd like to say, for all A, underscore double arrow, blah, just say, hey, fill this in for me, that'd be good. That I think would be a bit easier, actually. And some systems do something like that, don't they?
Agda.
Agda does. Oh, you see, Agda, just look to Agda for inspiration, it's a great system. We should throw GHC away. But then Agda wouldn't work anymore. Anyone else? Good. Oh, yeah.
What's the status of supercompilation?
What's the status of supercompilation? Oh, what an embarrassing question. So, supercompilation is another of those things that looks easier than it is. So I was, when Max, who was a super bright student, started working on supercompilation, I thought, by the end of this PhD, we will have GHC-supercompiler, it would be great. But we walked into the swamp and the sucking sounds happened, and so what we have is much better understanding of how supercompilers work. A really good PhD thesis, which is in the throes of writing now. It explains in a nice modular way what all the knobs are, what the design choices are, but not something that actually you can use for supercompile programs. Why not? The biggest problem is that you can often get very large code size explosions without big speed improvements. So the promise of the very small scale map fusion isn't really reflected at large. I think it has lots of potential, but we need to fling a few more PhD students in. Any volunteers? I think it's a very understudied problem. Really worth studying supercompilation. There's lots of meat to be had there. After all, think about it. Oh, sorry. Data center. I've got 10 seconds.
10 seconds.
Yes. If you're in a data center, right, you're consuming all these joules, executing instructions, stupid instructions. What are the stupid instructions doing? They're taking a data as a string and converting it to XML, and then converting it to some internal data structure, and then converting it back again. Abstraction is good for programmers, but it's really bad for energy. So we should just get rid of all those layers of abstraction, which means lots of fusion. Supercompilation is your friend. Really, all you do is execute the instructions that take the bits off the wire and put pixels on the screen, and really not much in between. Supercompilation is the way of the future, but we need to think a bit more about it first. End of story. Good. So keep us coming. More bug reports. Do work on those test cases. I'm vastly more motivated to work on a bug where there's a test case that's of a modest size than if I have to install 17 packages. I'm sorry, that's just human too. And please do join in. It really is a community project, not just something which you've got to persuade the people at HQ to do something about. Thanks very much.
Let's take